Good morning, everybody, and good afternoon as well. Hope you enjoyed yesterday's webinar, and today we are continuing in this webinar series. This will be the part 2. Again, it will be held by Vukash and Nikolic. And before we just continue, I would just like to show you everybody. Most of you have been asking me where all the download recording, where we can download the recordings of the previous webinars. So first of all, you can go to our website, and of course, before you go to the reseller area, you have to log in, and after that, you just go to the company over here, and then you at the bottom you'll find the reseller area. Just click there. And on the very third icon over here, you will see the reseller webinars. So this is the place where all the training sessions will be recorded. And we are also thinking that, as you can see here, we have SolidCAM 2020. And here you can see the basics of the post-processor part 1. And here is all of the webinars or the training sessions will be available. Now, of course, we are thinking maybe, to split to not be in 2020, but to have separate area, which will be the basics of post-processor. We are still thinking about it, and we will consider it. But anyway, this way or that way, we will also, at the end of these training sessions, we will send you all the kind of invitation letter, where I will call it also information letter, where we will put all links for the to watch it if you want, and also all the webinar or training content that we used in these training sessions, it will be also available. Okay, so now I will unmute you, Vukash, so you can share your screen. Let me just find you. Okay. Your presenter now.
Thank you, Daniel. Hello, everybody. Let me just make sure I'm sharing the right screen. Okay. Just a second. Okay. Now, tell me what you can see. Is it SolidWorks?
Yeah, we can.
Okay.
We can see it. Yeah, you can continue. Thank you.
Okay. Welcome back, everybody. Hope you enjoyed yesterday's webinar. Today we'll be continuing with the session and mainly following the agenda. And the first thing I wanted to do is to save the G-code from the 2019 version, then transfer to 2020 SolidCAM, and then to showcase our version control. And let's make sure that our post-processor works also in SolidCAM 2020. So I will start with that. Firstly, let's check what version of SolidCAM we are in. So it is SolidCAM 2019. Okay, now let's check the SolidCAM settings, that we have the right part and the post-processor loaded. So here are the post-processor settings. So the path is okay. It's in the SolidCAM 2019 SP2 version, and the CNC controller the same. So we can open our part and export the G-code. So if you go to Tools, SolidCAM, and open it. Now, sorry, everything is going on the other screen. Okay, so training part. Now, the procedure for this is just you generate the G-code, test it on the machine, make any changes to the post-processor, and when the G-code is good, you are okay to save that G-code. Now, let's just hit generate, and what we get is the clean G-code with trace level 0 that will be possible to run on the machine. Now let's go to File, Save As, and let's save to our path. But firstly, I want to talk about this folder. This is the SolidCam temporary files. You can find it in the, you can see the current user, app data, local, and then you have the SolidCam temporary files. This is where everything is saved by default. And if you have any accidental crash of the SolidCam or a power outage, the files will be saved here. And sometimes when you get the prompt window to load the temporary files or the compressed or the CAM project, this is where it's used for. So if you lost some work you saved because SolidCam crashed, you can look for it here. Also, this is the location where the yesterday mentioned pgen file is located. Now, let's navigate to our folder for Gcode. I will just use this. So, Gcode. Now we can't save it just here, but let's make a folder for a specific SolidCam version. So I'll use here new folder, and let's go with SolidCam 2019 SP2 hotfix 8. Okay. Now let's save our Gcode. Now the name is good to be the name of the CAM part, because you will know if you have multiple CAM parts and multiple Gcodes, you know which is for which. And now let's just add a SolidCam version just in case we misplace our parts. So I will use just SC 2019 SP2 hotfix 8 and just save. So let's check in the folder Gcode. Yes, the extension is now irrelevant. That's set by the VMID, and we can change it anytime, and we'll get to that later. So now we have our Gcode from 2019. Now let's transfer to SolidCam 2020. I will close my CAM part. Okay. And I will load the SolidCam 2020 through the plugins. So let's load it. I will have to restart SolidWorks. Oh, sorry for the blue screen. Okay, while we wait for SolidWorks to load, I hope that you all installed now the Visual Studio Code, set it up using the settings JSON file, so you have the coloring matched to our color scheme, so it will be easier for you to follow. Now, SolidCam is loading. There's nothing special we need to do except for to make the backups of the files that we used in the 2019 version, so we can use them in the 2020 version. Now, that's simple. Let's navigate back to our CAM part in Postprocessor. Okay. Now, I will just copy this folder and paste it back and rename it. Now, this is the 2020 version, SP1. No hotfixes yet. So here we have the identical training part that is still from the 2019 version, haven't opened it in the 2020. And let's do the same for the postprocessor. Let's just copy using Control-C and paste. Now you can hit F2, you can hit just the name if the file is already selected. Now let's go to 2020 SP1. And that's it. Now let's use these folders as our destination folders for the postprocessor and the CAM part. Okay, let's copy this path. Let's open SolidCam settings. Okay. Now, why we made a backup? Well, if you change something and it is different in the 2020 version, and you overwrite the part or the GPP that worked well in the 2019, you have a problem. You don't have anything to revert back to. So let's make sure this is okay. Great. 2020 user directories. Okay, this is already changed, but let's make sure it is good. Okay, copy and paste it here, and that should be all good. Now let's open the part in the 2020 version. Okay, it is good. Now we get a prompt. Because we have created the part in the 2019 and used it there, SolidCam recognizes that and alerts us that it is created in the previous version and will be converted. If we convert to 2020 version, we won't be able to open it in the 2019 version after that. So we can make a backup. It will just create a backup of the part in the 2019 version in the folder of the 2020, but we already made a backup and don't need to do this right now, so we can just continue. It will load the part. Okay. Now we see that the operations are not calculated. Why? Well, because we changed the version. If we just go calculate all, it will do it without any problems, and that's it. Now we can generate the Gcode and save it in a new location that will be designated to the 2020 version. So let's generate. Okay, we have our Gcode. Now let's save it also. Again, we are prompted to the temporary files. Let's move to the designated folder and let's make a new folder. SolidCam 2020 SP1. Okay. And let's save it here with the same rule that we add the SolidCam version to the CAM part name. SP1, and that's all. Now, how do I check for any differences? Well, there are multiple ways. The first way is to use an online diff checker. There's a great free and easy tool to use on diffchecker.com. You can use Simco, or you can use the, again, free software that we use called WinMerge. What it does is you can set it to track any changes in a folder, and as you develop your post-processor and as you make changes to it, it will highlight the changes, and if you have a file to compare to, it will tell you what are the differences. Now I will just make a new document and see that you have two fields. Now we will put our 2019 version code and 2020 version code here and compare them. Okay, so this is the 2020 version. Let's just select all, copy it, and let's put it here. Let's paste. Okay, and now let's open the 2020 version, 2019 version of the Gcode. Okay, let's just let's try like this. It won't. Okay, it opened it. Okay, so I will just copy the 2020 version here again. Okay, and if you hit this refresh button, okay, we have some changes. This is a just a new line, so that's no difference because of the copying. And the only difference is the time the G-codes are generated. So looking at this, there are no differences between the 2020 and the 2019 version. So all is good. You have a happy customer and he can continue working right away. So that will be it for the version control. Now, let's go back to the post processor. Let's close this. We can discard because we don't have any differences except the time. We can close this also. Let's minimize the folder and let's open our post processor. Now again, I'm going the way I like the most and is most secure. Let's open it and here it is. Now in Visual Studio Code, an easy thing to do and better if you have big screens and have a lot of screens is to make the font bigger. So you are you are better at focusing at the thing you're working at. So if you hold the control button and hit the plus, it will just maximize the font and the UI of the Visual Studio Code. So this makes us better to focus and it's easier to read now in the presentation. Now, I would like to go over the procedure definition again. And like Daniel said, procedure is like a sandwich. You have the top part, the opening part, you have everything in between, and you have the bottom piece of the bread. So the top piece of the bread is the name of the procedure that starts with the symbol and the procedure name. In between is everything you're putting in. So seasoning, salads, dressings, meat. So everything in between that makes it all work. It makes it a sandwich. And in the end is the bottom part of the bread or the end P that closes the procedure. So everything between the end P and the name of the procedure that starts with the symbol is a single procedure. Now, what are the procedure elements? The first element are the execution brackets. And now, because the init post is like the name said, the initialization procedure, there are no printouts in it, but the very next procedure, starter program, has a lot of them. So these, the curly brackets or braces, are the execution brackets. So everything between those brackets will be executed or printed in the G-code. So you see everything here will be shown as an output in the G-code. Now, the next element of the procedure are the commas. Now, the comma is just a, let's say, cosmetic feature. It is used to make the GPP file easier to read and better to handle. So let's say you have no spaces here. You would put a comma just to know that this is not the same variable and it's easier to differentiate what is a one hole. So now let's take a look in the G-code. Now let's say you have some braces here and else you would put just a comma and you would know, okay, this is for sure different. Now, the comma is optional. You can put it, you don't have to, but in a dense code that is a little harder to read, we tend to put it. Now, the next element is the semicolon. What does the semicolon do? It represents the comment. So everything that you want to comment out or not to print, you use the semicolon. So everything that has a semicolon in front of it will not be printed. Now let's make an example of it. So here we have a job name. Let's say we have a new line here, and let's put a semicolon, and I will just comment this for myself as a post writer, so I know what will be printed here. Let's say operation name will be printed. Operation name will be printed. Now this is one way to use a semicolon. Okay, or now let's save this. Let's go back to SolidCam. We can close the VMID. Let's generate the Gcode. Now remember, we put it in front of the job name. Let's generate the Gcode. Sorry. Now this is where we have put it. So in front of the job name. Now you see all the text we typed is not here because it is a comment. It is in the GPP, and that's only for you as a post writer or post editor. So this empty line is because we use the new line in the GPP. Let's go back. Now, other way to use the semicolon is to use it as a quick toggle switch. So if you want to not print this line, you will just add a semicolon in front of it, and it will not be printed. It would be considered as a comment, and that's it. So if you are editing a post and searching for a bug in it in the GPP file and you're suspect of something, you can just quickly comment it out and see what happens. And after that, you know what to implement in post, what to change in post, and so on. So let's save this change. Okay, I'm using Control S, as I mentioned yesterday. Okay, let's go back to SolidWorks, SolidCam. Let's generate the Gcode. Now, this Gcode file doesn't have the job name, so you don't see any job names here. So that's the other way you can use the semicolon. Okay, let's go back to the Visual Studio Code. Let's delete this semicolon. We need our job name. Let's save the change and let's move on. Now the next segment, or the next element of the procedure syntax is the apostrophes or the double quotation marks. What's the difference between them? Well, other than the characters, there is no difference in SolidWorks SolidCam GPP in the printout. So let's duplicate this line. We can just go and copy it. Let's go into new line, paste it, or if you have installed and used our settings file for the Visual Studio Code, you can just hit Control D and it will duplicate the line. I will undo this using the Control Z, and now we have two identical lines, and they have the apostrophes that suggest a string hardcoded printout. So everything in between the apostrophes will be printed the way it is. So it is used for comments, like you see here. We have open a bracket, parenthesis, job name, then an empty space, then the use of the variable. So it will print the name of the job, and in the end, in the apostrophes again, is a closed parenthesis. So everything that you want to be printed the way you stated, like this is, you put in the parentheses. So let's check out. We can close one of these. This one doesn't have the job name. Let's generate a new Gcode. Okay, let's go here and open the Visual Studio Code. Now you see everything that we put. So open parenthesis, job name, colon, then an empty space. You can see here. Also here we have an empty space, and then the operation name or the job name. Again, the apostrophes, and the closed parentheses. So this is the way we call it hard coding. Everything that you want to be printed the way you stated will be printed with the use of the apostrophes or the quotation marks. Now, why I duplicated this line? I want to show you that there is no difference between the quotation marks or the apostrophes. So if I delete this one and put a quotation mark, also delete this one and put a quotation mark, let's save the change to the GPP file, and let's generate the Gcode again. Okay. Now let's see, is there any difference? No. So you see, these two are identical. Okay, we can close this, go back to the Visual Studio Code. Now, one thing to note is that you can't use the combination of them. So if you open apostrophes, you have to use apostrophes. Now let's do that. Okay, if I delete this quotation mark and use an apostrophe, you see that right away something doesn't look right. And again, if the extensions and the settings.json file for the GPP files is installed, you will have this coloring also. So you see that everything is now in white. What that means? You see everything is in white. It means something is not good. Something is not in the correct syntax that it needs to be. So if I go and follow, let's say, the white line, go up, and I can see that this one is colored okay. This is colored okay. This also. So the last white line is the problem. And now we know, because we said here use the apostrophe and here use the quotation mark, it is not registering as a complete syntax. If we save this and try to generate the Gcode, we will get an error. So let's fix this. Let's delete the apostrophe and use the quotation mark. And you see everything is now again colored right, and it's good to use and won't create any errors because of the syntax. We can delete this line. Okay, save it, and move on to the next element of the procedure syntax. What it is? Well, the modality or use of the square brackets. What is the modality? Well, modality tells us if the value has changed. Now, how do we know that? If we go to trace 5, and let's change the trace level in our Gcode to level 5, we will get all the data. Now, let's save and generate the trace 5. Okay, let me move to the screen. Okay, now we have all of this data. Let's move to the, let's say, rapid line, or only, okay, rapid. Okay, so we have our coordinates. Now, the modality is used on many system variables, and you can know which one has a modality by searching the GPP help I showed yesterday, or by checking the trace 5 like I'm doing right now. Now let's zoom on this, and you can see that after every coordinate, so X, Y, Z, we have a letter, and that letter is here T, and here is F. Now what that means? Well, only true or false. So you have the expose minus 24, it is true. What the true means, the modality is true, so the value changed. Now, if we were to search further up, probably in the start of file or start of job, we will find another expose, and we would know the previous value. So this one has changed. Y pose also true, so it also changed, and the Z pose. Now, what do we do with this information? Well, if you use the square brackets, as we did here in the GPP file, let's go back to the rapid move and line. You see that X pose, Y pose, and Z pose are all in the square brackets. Now, the square brackets utilize the modality, and if you have them in the square brackets, if the value is not changed, it will not print it out. So everything that is in the square brackets and the modality for it is false, it will not be printed out. Now let's check that. So we have the modality in rapid move and also in line. If we take a look at our trace 5, so X pose, true, Y pose, true, Z pose, true. We have them all printed here. Okay, let's move to the next rapid move. X pose, it is false. So it is the same as the previous coordinate. Y pose, also false, but Z pose, true. By the logic of the square brackets and the modality, we should only get the Z pose. And that's right, what we got. So this is what the square brackets do, and we will be using them probably down the line in the webinar, but I hope you understood it. Let's now check the line also. So X pose false, Y pose false, Z pose again true, and feed is true. This is the first time we print out the line, so the value is true. And we get the Z pose and the feed. Also, we get the G0 and G1, but that will be covered later on. Now, the last element of the of the GPP procedure syntax for now will be the new block and new line commands. Now, what do they do? As the name says, new line prints out a new line, like you hit the enter on your keyboard. And the new block does also that, but it counts for another block number. So what are the block numbers? That are the numbers that are usually in front of the Gcode in the file we send to the machine. Now, some machines use the block numbers, some don't, some have specific formats, but what you need to know is every time you have the new block here, it will print out it in the Gcode. Now, let's test that out. We need to go back to the trace, and we have the block number generation set to false. For the block numbers to be printed out, you need to have the block number generation set to true, but also there's another variable that we will add that needs to be true as well. So let's change this to true. And the second variable is the block number exists. That means that machine supports the block numbers and has them as an option. So let's add block number, block num exists. So we have the suggestion here. Let's use it. Equals to true. Now, as these two variables are true, if one of them were false, we will not get the block number. So both of them are true. Let's now check out, did we get the block numbers? Let's also check we were to trace to level 0, so it is easier to see. Now, let's save this. Okay, and let's generate the Gcode. Okay, let me pull it up. Right, so we have the block numbers. Now you may ask why they are not here. Well, like I said, it depends, did you use the block, the new block or the new line command. Let's now check it in the tools used and the header of the Gcode. it will probably say new line, and that will mean we used only new line here. Okay, now, right, in the header, new line is used throughout the whole header, and that's why we don't get the new block. Now let's just test this. Let's change the user one to the NB. Let's save the change, and let's generate the Gcode again. Now let me just close all of these. Okay, now let's generate the Gcode again. Okay, pull up the file. I'm having an issue with the file, sorry. Okay, here it is. Now we set the new block to the user, and you can see. So the counting of the blocks starts here, and the only part that it printed the new block is here, just like we stated it. So let's revert the change back. We don't want to use it. Okay, new line. Now, the numbers that are shown and everything that you see in the new block and new line depends on the definition of block numbers. And we will cover that right now. Now, this definition comes under the variable formatting also, and we will cover that formatting. So let's check out. So we have the block number letter. Block number letter by default is set to n. And you see that on every machine. I haven't heard of a machine that has any other letter. So this is a string. You can state it or don't have to if you want to use n. It will be on by default. Now, like I said, block number exists and block number generate are logical variables that can be true or false. And if they are both true, it will print the block numbers. If the both are stated and one of them is not true, it won't print them. Now the next one is the block number format. This format is the same as for any other numeric or integer variable. So you will just say the number of decimal points. There are usually none, like you see in the picture on the right. And by the definition of the maximum number, you put the number of digits there. Block number says the first block number that will be printed. In our case, it is 10. Block number delta defines the step between two block numbers. So here, if the block number is 1, block number delta is also 1, it will count 1, 2, 3, 4. So, and the block number max is the maximum number that can be reached. If you exceed it, you will get an error while generating Gcode. Now let's go through the examples of this. So block number letter, it is usually the n, like I said. Block number exists is the does the machine have the block number option? Block number generate, do we generate the block numbers? And like I said, if they're both true, it will print it out. Now the next is the display formatting. Like I said, it's the same as the for other variables. So this format means that are 5 places before the decimal point. There are no decimal places after, and this letter P removes the decimal point. We'll cover that very soon. Now, the block number, like I said, is the first block number, the initial value. The block number delta is the step between block numbers. In our code that we are using, the step is 5 or the delta is 5. So we'll start from 10 and count in the steps of 5. And the maximum is what the name says, the maximum block number that can be reached. I will, for the example, I will say some small maximum number just to see what we get. So like you see here, our block number is not defined. Now, how is that? Well, the SolidCam will always have some default values and we'll follow them. Now, let's state the first block number. So block number, here we have the suggestion. Let's set it to, let's say 5. Or let's leave it to 10. And the block number delta will be 5. Okay, delta, let's set it to 5. Now, every next will be generated with the step of 5. So the CAM operator, if he needs to change anything in the Gcode, he has the space of 4 spaces to add any lines to the Gcode. Now, what I wanted to state is the block number maximum. Block number max, okay. That, let's say it is 100. We will reach that very soon. Now let's see what happens after we save this. Okay, just give me a second, switch to SolidCam, and let's generate. Oh, we get block number field too big. So this is what you will get. Now, there are many workarounds around this to reset the block number or something like that, but let's not talk about that right now. Okay, and let's see what we got. So only the line that was the maximum number and line after that and everything after is aborted. So you don't get the Gcode without the block numbers, you just get the bare Gcode that was printed until that. Okay, let's say the maximum number is, I don't know, 99,9999. Okay, let's save that. We won't get the error now. Now let's move on to the variable formatting. This is a pretty wide topic, but is pretty easy to understand. Sorry, just to load the correct slide. Okay. Okay. Now, the variable display formatting is used in, I think, every post. It's not hard to understand. It is pretty powerful, if you ask me, and it has a lot of options. Now, you see this formula that variable for the format is equal to apostrophe and then a lot of elements. So prefix, sign, leading zeros, the integer part, the fraction part, and the decimal point, trailing zeros, options, and postfix, and all ends with the apostrophe. Now, if you take a look at this, it is pretty scary to look at, but take a look at the bottom picture and you can see that here is the apostrophe at the beginning, a prefix, there is no sign, there is no leading zeros, integer part is 5, decimal point, then the fraction, and just the postfix. So you will very, very rarely use all of this, but you have it at your disposal if you need to. So here you see it is a bit more complex, but again, after we cover that parts, you will understand all of it. So let's move on. The integer is not first in the line of in the sequence, but I think that it is most used along with the decimal point and the fraction. So the integer is the first number before the decimal point, and it states how many digits can be before the decimal point. Now, if you say 5, so the maximum number is 99,999. So that's the maximum, that's the biggest 5-digit number that can be printed out. Now, if the number is less than 5 digits, it will just print it out. No need, no empty spaces, no nothing. But if we add a slash and define another number, it states, like here says, minimum number of digits that must be generated. So in the example, if you have 8 maximum digits and 5 minimum digits, but here are also 3 digits in our coordinate, it will print the zeros. So you will get 0, 0, that are the 2 empty spaces that we have, and then 1, 2, 3, that is from the coordinate. So we have to fill this 5 space like this says, at least 5 before and 4 after. Now the fraction stays the same. All rules apply equally. So if you have 7 digits maximum, but you want to define the 4 digits, you have 4, 5, 6, and then 0. If we had 5 here, we will have another 0 after it. Now let's move to the prefix and postfix. They are called affixes, and they are optional. So what is a prefix and postfix? That are the values or characters that are printed before and after the numeric part of the variable. So these can be only used on numeric variables and are not obligatory. So you don't have to use them. They are defined between the greater than and less than characters, and the maximum length is 31 characters, as it is said. So this is most commonly used to define the axis letters, like you see here. So we will put X and then the numeric value, and here you see an empty space. Why we use the empty space? Well, to separate our variables in the trace 0 printout of the Gcode. So prefixes and postfixes can contain any any string, so we can test it right now. We have our Gcode format, and here is the prefix and postfix. Postfix is just an empty space, just to separate each coordinate. And if we say here just Gcode and save it like this, and let's generate the Gcode. Let's close all of these previously generated. Let's generate. Okay, let me just pull up. Okay, now you see that we have Gcode every time that G format is used. This is, like we said, hard-coded, but G54 is now Gcode 54, G43 is Gcode 43. So this is where the prefixes and postfixes are used. This is the postfix. So you see an empty space here, even though you don't see it like this if you don't select it, but this is the formatting of the variable that is doing it. So let's revert back. Also, I would like to turn off the block numbers. So let's make this false, and let's delete the code, leave only the G. Okay, let's move on. The sign. The sign comes after the prefix and is optional. So if you don't put anything, GPP will follow the default. That is, if the value is positive, it won't print anything. But if the value is negative, it will print only a minus sign. So if we use a plus, So we will just, after the prefix, if we had the prefix here, add a plus, and every positive value will have a plus. Negative values will stay negative, so no worries, but some machines require to state the sign of the value, so we use this as a option. If we put the minus, it will just indicate negative numbers, so positive will stay positive. It will just print an empty space because of the minus in the format, but it won't convert positive to negative, so don't worry. Basically, none and minus are pretty much the same. Leading zeros. Now, leading zeros, something similar to the minimum number of decimal points or the spaces before and after the decimal point. If you say you have the maximum number of 5 digits and you use the leading zeros, you will have the all 5 spaces taken up. Now, if you use the Z or Z as the symbol, you will have zeros. So here is the example. There are 3 digits, but it adds 2 zeros in front of them as leading zeros. If we use only a empty space here, so 1 space, it will fill that with an empty space. And if you use nothing, it won't add anything. This will be the format of the value. So let's test the leading zeros. Now let's go again with the Gcode. And if I add here the Z, one thing to know is you have to follow the sequence of the variable formatting options that is in the formula. Also, this presentation will be shared in the webinar content. So let's add Z in front of 5 as leading zeros. Let's save the change. Okay, let's generate the Gcode. Okay, and now here we have G54. So we have leading zeros. There are 2 digits, but the format says we can have 5. So we have another 3 leading zeros. Now, if we want to use leading spaces, let's delete the Z and just use an empty space. Okay, let's save this. Go back to SolidCam. Let's generate the Gcode now. And what we got? Whoa, a lot of spaces. How much? Well, how much the zeros would be? 1, 2, and 3. So this is the use. Again, some machines require a certain number of digits, and this is one way to use it. So let's close this. Let's go back to the presentation. Okay. Next is trailing zeros. Now, between the leading zeros and trailing zeros goes the integer decimal point and the fraction, but they are the most common use, so they were presented first. Now, the trailing zeros is identical to leading zeros, just for the integer, the fraction part of the variable. So it will have the same effect like I showed earlier. And for the end are the options. Options manipulate the value of the variable, and they can manipulate the value, also the sign or the decimal points. So what are the options? First are the scaling factors. You can multiply the value with the scaling factor or divide it. So if you have a turning machine and you have the x coordinate and using the diameter, you would use the ×2 and put it in the variable format. Now let's test it. Now, if I go to, let's delete this, revert back, and let's say that we use let's use it here, because we also, or let's use it on the X format. Now, what I wanted to talk about also, you see that first format is defined is X next, and this format is not the system formatting variable. Now, by standardization, we don't use the prefix of the variable type on the formatting. So the question was, or the question for yesterday's webinar was that this is not correct, that this is not an integer variable, but it is a string, like the pop-up window says. But because the formatting variables don't use the prefixes and underscore, this is the name of the variable. If you take a look, I compensation, and then just add the underscore and F. So this is why the I is here, not to confuse anyone. Let's go back here. The Xnext format is not a system format, so we needed to declare it. And here you see format output, Xnext, Ynext, and Znext. So we had to declare it, and by following the standardization, just it goes with the name of the variable underscore F. And we declared it pretty simply. So X, 5 digits integer, decimal point, 3 fraction, an empty space to separate the values, and that's it. Now, Ynext and Znext are following the same example, and now the expose formatting, that is a system variable, like you can see here, system variable, and if I hover here, it is a user. Now, because it is a system variable, we don't need to declare it up here, but if I wanted to use the same format as the Xnext, I don't have to type the same as the Xnext. I can just say that format for the expose is same as the format for the Xnext. So that's why you see that here. And now everything that I change here will apply also for the expose formatting. Now let's use the scaling factor. All the options for the variable definition are set into the parentheses or the brackets. So if you open it, let's close it also, and let's say set a scaling factor. Let's say just times 10, so it can be easy to spot. Let's save it, and let's generate the Gcode and see what we got. Okay, generate, go back. If I increase the font, let's find the X values. Yes, you see 1350, 1240, so a lot bigger. That's the scaling factor. The same is for the scaling factor of division. So if I divide this by 10, let's save it, generate the Gcode just to see what we got. Okay, let's go back. Now the same values that were in the thousands are now 10 times smaller. Okay, let's go back to the presentation. Let's close this and let's continue. The next option is the letter D. D deletes if 0. So if the value of the variable is 0, it will not be printed. This is something similar as the modality, but not quite sure. You need the coordinate after all, but it is an option, a rarely used option to be honest, but you can do that. And goes with the no decimal point. So if it will just delete the decimal point. If you have 123.456, it will just make it a one number without the without the decimal point. Now the P is a conditional decimal point. The number will not have the decimal point only if it's a whole integer number. So if you have 24.0, you will have just 24 without the decimal point. And the invert just inverts the plus to minus and minus to plus. Now, here are the examples. You can see we show the scaling factor. We talked about the deletive 0. So if we have expose as a 0 and the it will print just it won't print anything. So it won't print even the X from the formatting, nothing. Just if the value is 0. So n deletes the decimal point. Like I said, it deletes it. This, I don't know, it can be used in the machines that use microns. Conditional decimal point is used somewhere where you want also to save some space, not using the one character space for the decimal point, and if you have the zeros after it. But some machines require a decimal point after the value of the coordinate, and invert, like I said, just inverts the sign. That will be it for today from me. Let's see if we have any questions to answer them. Daniel?
Okay, thank you, Kashin, for this wonderful training for the second part. I hope everybody enjoyed. Of course, we have a lot of questions, and let's get started with. I would go with the first question that was coming from Anthony, like what is the home number? What are the main difference between the home number variable and the MAC number? Basically, Anthony, it's like this: home number. It has, once you start to define the max and positions, each of those have unique home number. Okay. While the MAC number, it's just the MAC number that you define. So you can have MAC 1, position 2, 3, 4, 5, 6. In each of these MAC, it will be 1, while the home number will be changed. It will be 1, 2, 3, 4, 5, 6, and so on. Now, you also asked, like, what is the main difference between an L and B. Later in this session, the Vukasin actually explained the new line will basically just create the empty block, while the new block will take the function of the new block generation from the option or from the settings. There is also another very nice question. Actually, it's coming also from the Anthony. It's like the very first empty line that is generated inside the trace. So sorry, Vukasin, can you please? I would like to, if it's possible, that you give me also the. Where are you now? Okay, I'll try to like. Can you please go to the post itself?
Okay. Do you want me to give you the screen or open the post?
Just open the post and go to the very first NL of the post.
Sure. Okay, let's go. Here it is.
Okay, so Anthony, the new line in this case, you just remove this new line, the very first one. Vukasin, you can do it right now. Okay. Like this, save it and just generate the Gcode.
Okay.
And you will see that there is no very first new line generated there. Okay, so just this very first new line, it's generated on this way, and hope this answered to your question. There's another question like why we don't see in the rapid move the H pose, M pose, L pose, and those things. Okay, guys, regarding to the coordinate sets, we'll discuss about this in later trainings. We will mention them. For this, we have a great webinar that was also given earlier, where we explain in depth what is the main difference between the pose, L pose, H pose, M pose, T pose, TR pose, and O pose. Okay, where we describe in details where you want to use in each kinematic. In the rapid move, X5T changing plus true. Anthony, your last question, I'm not sure if I really understood it. So if you can declare it again, or you can maybe write us write us something again, or maybe an email, that will be appreciable. Andre have a very nice question. It was like about the block number. It's not a command. It is a tagline. So why there is no block number at first? So basically, why we cannot just say like N10 and then N995, and then the SolidCam will start once he reached this block number to start the generation of the new block again. Okay, the question, it's completely fine. Why the SolidCam don't start again from the beginning, but it will just pop up the message and then he will continue on. For the SolidCam in the past defined this function. Of course, how the SolidCam raised and how the SolidCam was improving, we saw it that in each post-processor, the block number can be used differently. Okay, first of all, second of all, there is a very advanced Milter machines where the new block completely differently behaves, and it changed the rule how it should work. In the next webinar, in the next training, which will be held tomorrow at the same time, we'll show you how you can create your own block number generation. And basically with that, you can have a full control how and what you want to print out. Okay, in this way, you can also, once we reach the limit of block number of 995, which is the limit of the machine capabilities, we can create a new Gcode, for example. Okay, so this is also a very great example that we'll show also in this training. Good question, Andre. So also, why system integer parameter have string values in trace? Okay, this is also a very good question. Kashin, can you also generate trace and try to find the arc direction, for example? Okay, so guys, now I will explain the question itself. So if you analyze a little bit the trace inside SolidCam, you can see that some of the values, can you select in line 4446, Kashin? It is the arc direction. Okay, so as you can see here, the Andre's questions was, okay, why the arc direction, which is in the fact integer, have this CV, which is the clockwise, and this is, by the way, not a string at all. So why we have such a thing in SolidCam? Okay, so for the post-processor developers in the past, it was very important that to not see here 0 and 1, because then he must check, is this a clockwise or counterclockwise? What means 0? What means 1? So in the fact, if you try to print arc O direction or direction, basically the clockwise will not be printed as clockwise, but it will be printed as 0 or 1. Okay, we'll also explain this in depth. I will make sure this Kashin and myself, we will discuss how to present this in tomorrow's training. Very good question. Why this was useful and why we are doing it this way, and how you can actually find what is the real value actually in the help file. Okay, good question. Why we don't x next f variable? Why did you do? Okay, good question. Why did you decline the x next f variable if it's a system variable? Okay, then it's a very nice question. When in the past, of course, I always say what was happening in the past. You know, when we start to make the definition, many stuff was not unknown how it will be later on used inside post-processors. So in fact, yes, the x next is the system variable, but there are only few variables that are coming like a system for the displaying format. Okay, very few ones, and you can check that if you go, can you Kashin open the Visual Studio Code and go to the xnextf? Okay, as you can see, this is a user variable. If you try to declare, for example, I don't know, like a pose f, the SolidCam will give you, the error that it's not possible. Can you, Kashin, for now, just write the a pose underscore f? As you can see, this is a system variable. Okay, this is coming from the system and it was from the past. Later, how the SolidCam involved, basically we said, okay, let's do it in different way. We cannot put all system variables and also the formatting, but let's allow post-processor developers to define whatever they want. And this is why we are showing you how it is best to define it by doing the underscore f. So whenever you use, this was also the question from yesterday. When you use this I compensation, you can see on the top, we defined the global integer I compensation in the block of 3. But later on, we also defined for the formatting of this variable, we create a global string which call it exactly the same as the integer one, but we just added the postfix of underscore f. So whenever you add an underscore f, it means that you want to format wherever it's the I compensation is printed. And this is basically it. So there are very few system variable string formatting that we will see in SolidCam. Most of them, it's actually not declared. So if in Visual Studio Code you see this comment, as you can see in front of yourself, it's system variable, you don't have to declare it. For all of others, yes, you have to declare it. Okay, Justin, there also, if we need to repeat block number, and this is also the question from Andre. So we will give you a good example how to proceed with this. All right, this was it. I'm very glad that you have questions. I really it means that it was very interesting webinar. This is how I'm getting this feeling about the webinar. So we'll continue, guys, tomorrow at the same time. Don't hesitate to prepare the questions, and you can also drop us here. I forgot one thing to put, the SolidCam support team, so you can contact us in any time. But I'll do that later tomorrow once we repeat and go into the third part of the training. Kashin, thank you again. Thank you all, guys, for joining us today, and see you tomorrow.
Thank you, guys. Bye.